YouTube. In this video we're going to be discussing and defining the 6 trigonometric ratios that you've often heard so much of: sine, cosine, tangent, cosecant, secant, and cotangent, what they are. Okay, we're going to start by pointing out the fact that they are ratios. Okay, and when we talk about a ratio is really just a comparison of two things that can be written as a fraction, as in like a comparison of a to b would be a over b. We could also write this as a to b, or as in the preposition a to b, but we tend to write these things in fraction form in trig a lot of the time. So we're comparing sides of a triangle, essentially, is what we're doing. And these 6 trig functions, as I already mentioned, are the sine, cosine, and tangent, which are our primary 3. And then we say cosecant, secant, and cotangent, which are the reciprocal functions, and they are abbreviated thusly. So a few ones to remember really quickly, like this one here, we say secant here. A lot of people like to say this is like maybe like, I guess it's cosine. Some people call cosine cos, they call that cosecant on accident. But I do want to point out that these are the 6 trig functions, and these are how they're abbreviated. But what we're going to do is we're going to define these 6 trig functions. So if you have a piece of paper handy, you want to sketch in a right triangle, the first thing we want to mention here is this. We say we have a right triangle, and we want the angle A to be an acute angle of this right triangle. So we say, mentioning that it's a right triangle, A we're going to allow to be one of these two other vertices. And I'm going to call this the angle A here, we'll call this one B. And this one down here, C. But with respect to angle A, which is this one right here, we notice that if we were to talk about the relationship of the sides of this triangle, we say the hypotenuse is always the longest side of this triangle. Okay, and then the other two parts of this triangle we refer to as the legs. Okay, so we have a leg and a leg. But we also kind of refer to this these legs here as being in position with A, you know, where they are with respect to A. So we call this leg opposite A, the opposite leg, opposite, OPP. And then down here we're going to want to label this one the adjacent leg, and adjacent just means right next to, okay? But the way we define these 6 trig functions is kind of like asking this question. When we talk about sine, we define sine as being the opposite side over the hypotenuse, and really what we're saying is, well, the sine of A, what could you tell me about how the opposite side of A compares to the hypotenuse of A on this triangle? So when we look at this triangle, we're saying this angle must be so big that this opposite side compares to this side in a certain way. Okay, so we're going to get used to writing these trig ratios thusly, but in order to do this, what we're going to do is we're going to write out so, ka, toa. Okay, and what we mean by this is every time you see O, we mean opposite. Anytime you say A, we mean adjacent. Anytime you see H, we mean hypotenuse. But what we're basically saying is this: the sine, the S, sine of an angle, so sine of A here, is equal to the opposite over hypotenuse. We notice here that I have the opposite over the hypotenuse. So means that sine is the opposite of that angle over the hypotenuse to that angle. And we say, well, cosine, what would cosine be? Ka. And cosine, we look up here, cosine of A, we would say it'd be the adjacent side over the hypotenuse. Okay. And then last but not least, we say toa, which stands for opposite over hypotenuse. We notice that tangent is opposite over hypotenuse. So you notice here that I say not only opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, but I've also given things letters. So I'm actually going to re-sketch the triangle that we have written over here to clean this up a little bit. But I had called this upper C, upper A, and upper B, and we said this is the angle I'm comparing everything to, but it is generally good practice to put a lowercase a across from uppercase A, a lowercase c across from uppercase C, and a lowercase b from upper B across from it. But we say, for instance, the sine of angle A, we would say the sine of A would be equal to its opposite side over hypotenuse side. And in this case, we could say we could re-express this as A over C, or whatever the length of A is over the length of C. That would be the sine of A. And we just got that from following our SOHCAHTOA rule. And that's what we're going to be using a lot of the time. Okay. So one thing I want to point out here is this. Underneath sine, you notice that I have cosecant of A as well. And so it's the same angle, but we say, well, how am I going to do cosecant? What I want to point out here is this. These bottom 3, these are reciprocals of the top 3. So the nice thing about these bottom 3 is this: if you ever want to find the cosecant or secant or cotangent of a given angle, what we do is we would find the original 3 first and then just reciprocate them, because if you notice this here, I say the sine of A is the opposite over hypotenuse. Let's say we already knew that equaled A over C. Well, then to find the cosecant of A, what we would do is we would just reciprocate this and call this C over A, which in reality this is the hypotenuse over the opposite side. When you look at our triangle here, this would be our hypotenuse over the opposite to our angle A here. Okay. So essentially, we'll find the original three using SOHCAHTOA and then use those to reciprocate and find the other three. Okay, so really quickly here, I want to kind of point something out. We say the abbreviations OPP, ADJ, and HYP represent the lengths of the three sides of the right triangle. We say note that the ratios in the second row are the reciprocals of the ratios in the first row. So like what we just said here, these are just reciprocals. This is the formal definition of that. It essentially says that sine is the reciprocal of cosecant, and cosecant is the reciprocal of sine. So for example here, let's say we already knew that the sine of theta was equal to 3 over 4. Then what we could do is we could say, well, instead of writing a sine up here, we could just write 3/4. We could say 3/4 is equal to 1 over cosecant, okay? But anybody who knows anything about math knows that we could reciprocate both of these sides and they're still going to be equal. And so what you notice here is I get 4 over 3 is equal to the cosecant of theta over 1, which is really just the cosecant of theta. So in other words, cosecant is 4 over 3 and sine 3 over 4, okay? So reciprocals, remember this. So where do these right triangle trig things come in handy? Well, when we deal with right triangles. So here's what we're going to do. We're going to deal with this triangle ABC, and we're going to sketch a picture of ABC. It's good to just kind of have a right triangle in general that you always sketch. But we say C is the 90-degree angle. So we're going to label this capital C. And we'll label these two over here, we'll label this capital A and capital B respectively. And just like we did before up here, we're going to label this lowercase a, lowercase b, and lowercase c across from those respectively, those vertices. But here's what we know. We know that A is equal to 6 units and that C is equal to 10 units. And we want to find the 6 trig functions or trig ratios of angle A. So what this means is we are going to find the sine of A, and we write it this way. We're going to find the cosine of A, and we're going to write it this way. And we say the tangent of A, we write it this way. And we do not mean sine times A or cosine times A or tangent times A. We mean sine of the angle A. So really what we're asking is, when we go look at this angle A, sine, remember sine is so, opposite over hypotenuse, we're saying how does the opposite of A, opposite, compared to the hypotenuse of A? And what we're really saying is the opposite side, 6, compares with the hypotenuse in this 6 to 10 ratio, and we should always reduce if we can. So this is a 3/5 ratio. So this would be the sine of A. It would be 3 over 5. So just like we did with sine, we're going to do the same thing with cosine. We say cosine of A. A is right here. We say the cosine of this is A over H, or adjacent over hypotenuse. So we would get this B over hypotenuse. So in this case, we get B over 10. Now there's only one problem with this, is we don't know what B is. But the good news is when you're dealing with a right triangle and there are two things you don't know and one thing you don't know and two things you do know, is we can set up the Pythagorean theorem, which is a squared plus b squared equals c squared. So in this case we're going to say this. We say a squared, which is 6 squared, plus b squared, which we don't know b, is equal to our c squared, which is 10 squared. And this all simplifies down into 36 plus b squared equals 100. So what we want to do now is we want to solve for b squared, which involves getting b squared by itself. So we're going to subtract 36 from both sides. We'll bring this up here, but we get b squared equals 100 minus 36 is 64. And of course, to undo this b squared, we'll square root. So we get this. We get b equals 8. And we always, when you find something out about a triangle, you always go fill it in on the side. So now we can say adjacent over hypotenuse is 8 over 10. And I do want to point this out. The tangent is always or opposite over adjacent. So if this is angle A, tangent of A, we say opposite over adjacent. We would get 6 over 8. And that was easy. I think this is a really easy thing to do. And the nice thing about the other three is this. If we want the cosecant of A, we need to remember cosecant is the reciprocal of sine. We get 5 over 3. Or if we want secant, which is the reciprocal of cosine, we would get the 8 over 10 value, which is 4/5, by the way. We would get that as being 5/4 here. And then the cotangent, which is the reciprocal of tangent of A, would be, instead of 6/8 or 3/4, which I should have simplified it down into, it'd be 4/3. But this is how we use the definition of the 6 trig ratios to find the 6 trig ratios. Cheers.